An interior designer creates a line of decorative teakwood prisms that are sold in sets of 3. All the sets are similar to the ones shown below, with the side lengths changing depending on the desired size of the decorative prisms. The volumes of the prisms can be described by the functions p of x equals 1 half x times 3 fourths x times x plus 1, q of x equals x cubed, and r of x equals 3 fourths x times 2x. Write the most simplified form of t of x, form for t of x, a function that describes the volume of teakwood needed for a set of decorative prisms. Okay, so we're looking for t of x, which will be the sum of these 3 prism volumes. And so we can use a table to find the values of the 3 functions, add them together, and then find an equation to represent those values. And since it's volume, I'm going to start, we know it's positive numbers. I'm just going to start at 0, and I'm going to go up by 1. Just remember that your change in x, or the amount that x changes each time, needs to be constant. So whatever values you choose, make sure it's going up by a constant amount, constant rate. Um, and so let's go ahead and find p of x, q of x, and r of x. So you can definitely just plug these in and keep it in fractions, or you can use your calculator and do it in decimals. I am actually just going to use the calculator just for sake of time and simplicity of this video. I'm not going to show how to compute each one. I'm just going to go ahead and show the results for each of these. So if we plug in 0, we get 0. For 1, we get 75 hundredths. For 2, we get 4.5. For 3, we get 13.5. And for 4, we get 30. And then plugging in the next one, we can do this one in our head. So 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64. And then lastly, for r of x, then if we plug in 0, we get 0. If we plug in 1, we get 1.5. If we plug in 2, we get 12, and then we get 40.5, and lastly we get 96. Okay, so now that we've got those values, again, I'm just doing these decimal form, but if you have fractions, it will be the same thing, just in fraction form. So let's go ahead and find for t of x, which is just the 3 added together. We know it's going to be p of x plus q of x plus r of x. So we can just add together. So 0 plus 0 plus 0 is just 0. 75 hundredths plus 1 plus 1.5 just gives us 3 and 25 hundredths. Adding together the next 3, we get 24.5. And then 13.5 plus 27 plus 40.5, we get 81. And lastly, 30 plus 64 plus 96, we get 190. And now we can find the differences of these, and that will help us know what type of equation it is. So subtracting, doing 190 minus 81, we get 109. 81 minus 24.5, get 56.5. 24.5 minus 3 and 25 hundredths, we get 21 and 25 hundredths. And then 3 and 25 hundredths minus 0 is just 3 and 25 hundredths. Okay, and then since none of these are constant, none of them are the same, then we can keep going. So 109 minus 56.5 is 52.5. 56.5 minus 21 and 25 hundredths is 25 and 25 hundredths. 21 and 25 hundredths minus 3 and 25 hundredths is 18. So we see that was our first difference. This one's our second. Again, they're not constants, so let's keep going. So 51.5 minus 25 and 25 hundredths, we get 17 and 25 hundredths. And 25 and 25 hundredths minus 18 is, again, 17 and 25 hundredths. Okay, so we see that we do have a matching third constant term, which means it's going to be a cubic function. So let's pull out our rules from chapter 1 about cubic functions, and let's go ahead and find the different values. So we need to find a, b, c, and d. Remember, it's ax cubed plus bx squared plus cx plus d. So to find a, we know that 6a will equal the third difference, which is 17 and 25 hundredths. So to solve there, you can divide by 6. And so we get A equals 2 and 875 hundredths. And then if the answer of this is actually going to be in fraction form, so let's go ahead and we can just convert that by just using a calculator and pressing the math menu and fraction and pressing enter. And we see that's equal to 23 eighths. Okay, so that is our A value. And now let's find our B value. So we know 6A plus 2B is equal to the second difference. And it's the second difference coming from 0 and 1 going to the side where x gets bigger. So it's basically just our second difference that we have. We have that will equal 18. So 6A we just saw is equal to 17 and 25 hundredths plus 2B equals 18. Subtracting 17 and 25 hundredths on each side, we get 2B equals 75 hundredths. And if we divide by 2 on each side, then we get B, actually I'm going to write it right here, B equals 375 hundredths. Okay, so now let's find C. So A plus B plus C will equal the first difference, which, and that's between x equals 0 and x equals 1, which is 3 and 25 hundredths. So A and B, well, A is going to be here. There's our decimal form and then fraction. Oh, let's go ahead and convert also B into a fraction because we'll need that for the end here. So that's 3/8 by the way. Okay, so now let's go ahead and add together these decimals. So we have 2 and 875 hundredths plus 375 hundredths plus C equals 3 and 25 hundredths. So adding the two decimals together, then we get 3 and 25 hundredths plus C equals 3 and 25 hundredths. And so we know, the only thing that C can be here is 0. We can go ahead and just finish it formally by subtracting 3 and 25 hundredths on each. So we get C equals 0. And then lastly, D equals T of 0. So what's T when x equals 0? Well, it's just 0. So D will equal 0. So then in our final equation, that we know A is going to be, we're going to put it in fraction form as 23 eighths. B will be 3 eighths. C is 0, and so we don't even have to write it. And then D is just 0 as well. So our final answer is T of x equals 23 eighths times x cubed plus 3 eighths times x squared.